This is 5.1 part 3. We're going to continue filling in this table together. I showed you how to go through the table in the previous video. Now we're just going to fill it in quickly. So starting from the column over here, we have a is equal to negative 6. We have a is equal to negative 0.3. And we have a is equal to negative 0.6. And so we're going to go in and fill in our data using our calculations. Again, you can simply multiply the x squared value here, the y value of the y is equal to x squared, by negative 6 or whatever that a value is. Or you can go in and plug it in to your equation much like we did previously. So we get negative 54, negative 24, negative 6, 0, negative 6, negative 24, and negative 54. Oops. And over here we get negative 2.7, negative 1.2, negative 0.3, 0, negative 0.3, negative 1.2, and negative 2.7. And likewise, we have coefficient or a value of negative 0.6. So we're doing negative 0.6 times 9, and that would give us negative 5.4. Then negative 2.4 over here. Then negative 0.6 over here. 0 here. Again, we have a y-intercept of 0, 0. Then negative 0.6 again. Oops, here. And then negative 2.4. And then negative 5.4. And so now we have all the values required to plot these different graphs on the grid below. We're going to do the same idea. We'll start off with our A's being negative but larger than 1. So, for example, A is negative 1, or A being negative but 1 or larger. So, A is negative 1, A is negative 3, A is negative 6. And then afterwards, we're going to plot the A being negative but the number itself being smaller than 1. So, negative 0.3, negative 0.6, and see how they affect our graphs. So let's start off over here. Here you'll notice that I left more room for the negative values on the grid. We're going to start off with plotting our y is equal to x squared using our data that we have. It's on the previous page, but if you have it printed, you can have it side by side. It's much easier to read. So we'll start off by labeling our axes. So here we have 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, then negative 7, and then here we have 1, 2, 3, 4, 5, 6, 7. And then here we can go 1, 2, 3, 4, and then we can go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, and negative 8. Again, we won't hit all the numbers, but we can estimate roughly where the parabola will go based on the dots that we can connect. So y is equal to x squared. When we have y is equal to negative 3, we have 9. We can't go that high, but let's try it. Y is equal to negative 2. We have 4. We can do that. When we have y is equal to negative 1, we have 1. When we have y is equal to 0, we have 0. Y is equal to 1, we have 1. Y is equal to 2, we have 2. And so now we can connect these dots here and here. We can extend that here. And this is y is equal to x squared. So what we're going to do now is we're going to plot or graph the first transformation with the negative a, which is negative 1a, a negative 1 x squared. So in our table where we had negative 1 x squared, this one here, we're going to plot these values here and see what the effect is of putting that negative a in the front. So when we had a value of x of 0, our y was also 0. When we had a value of x that was negative 3, we had negative 9, so somewhere down here. I'm just going to draw that so we know where to aim. You could extend your grid if you needed to. When we had negative 2, that was negative 4. When we had negative 1, that was negative 1. When we had 1, that was 1. When we had 2, that was 4. Or negative 4, rather. And negative 1. And then same idea, 3, we had roughly 9. But what I want you to see here is we can connect these dots. We could extend if we needed to, but no need at this point. So this is y is equal to negative x squared. What I want you to see is that nothing really happened to the width of the parabola. It wasn't really stretched or made wider or made narrower. But what you can notice is that there was a reflection that happened. The y is equal to x squared. When you add that negative in the front, you reflect about the x-axis. This x-axis over here, this is the x-axis. This is the y-axis. The x-axis in a way acts like a mirror that flips the parabola over. So adding that negative takes the positive version of that parabola and then brings it into the negative quadrants below the positive quadrant. So it flips it about the x-axis over here. And so you can do the same thing with the other graphs to see that that's the case. So for example, if we graph negative 3x squared, let's choose a different color for that. So let's have our blue over here. For negative 3x squared, when we had negative 3, it was negative 27. We can't really plot that. But we can do when it was negative 1, we had negative 3. When it was 0, we had 0. When it was 1, we had negative 3. And so what you'll notice is that we still have a narrowing because the a value is larger than 1, but it's still flipped about the x-axis. The opening is still at the bottom. So this is y is equal to negative 3x squared. So as soon as we put that negative in front of the a, our parabola opens from the bottom. It's flipped from the original where the parabola opens from the top. The 3 value here still serves to narrow our parabola. And then likewise, you could also plot the y is equal to negative 6x squared. So let's choose a different color here. So when we have y is equal to negative 1, we have y is equal to negative 6 here. 0, 0, 1, negative 6. And again, you'll notice that our parabola is narrower than before. This is y is equal to negative 6x squared. So narrower than before, and still flipped about the x-axis, still with the opening being at the bottom. And so you can do the same thing for the other coefficients. What you would see is for the other coefficients over here, that we're going to have a compression happening, so a wider base, but flipped. The parabola will open from the bottom. So the main effect of the negative sign is that we have a reflection that occurs. So we're going to answer the questions 2 and 3 over here. And then when we're done these questions, we're going to make another video where we're going to plot the remaining functions, negative 0.3x squared and negative 0.6x squared. So how is the graph of y is equal to negative x squared related to the graph of y is equal to x squared. So we know they're similar to each other. We know there are some differences as well. But the way they're related is that they are a reflection of each other. They're a reflection about the x-axis. They are essentially a mirror image of each other. How are the graphs negative 3x squared and negative 6x squared related to the graph of yx squared? Well, there's two parts to that answer. First of all, because of the 3 and the 6 being a's that are bigger than 1, ignoring the sign, just looking at a's being bigger than 1, we know that they are narrower or stretched and rise faster than the y is equal to x squared. That's part of the answer. The other part as well is because of this negative compared to the x squared, they are reflections as well. So they are reflections or reflected. We can take a look at number 4 here. Although we haven't plotted them, we can make some reasonable assumptions and some conclusions based on our work that we've done so far. How are the graphs of negative 0.3x squared and negative 0.6x squared related to the graph of y is equal to x squared? Well, again, we know first of all this negative value here makes it a reflection. So they are reflected compared to y is equal to x squared. But in addition to that, they're also wider. And the reason that they're wider than y is equal to x squared is because of this 0.6 and 0.3. Ignoring the sign, these a's are smaller than 1, so it compresses the parabola and makes it wider overall at the vertex compared to y is equal to x squared. So if we look at question number 5a over here and 5b over here, how would the graphs of the following equations relate to y is equal to x squared? Well, let's take a look. Our 25 piece, that's an a that's considered bigger than 1. So what that means is that this parabola is going to be narrower and rises 25 times faster. Narrower and rises 25 times faster. And I shouldn't say rises this time. Here's the reason I shouldn't say rises. It's because of that negative in the front. So it's reflected. So in other words, I should be saying it's narrower and decreases 25 times faster. And decreases 25 times faster. Whereas if we look at this one over here, because of this 0.7, ignoring the sign, this is an a less than 1, we know that it's going to be wider and decreases at a slower rate. And the reason I'm saying decreases at a slower rate is because of this negative here. So it is reflected compared to the x squared. It's going to be opening from the bottom instead of opening from the top, like the positive x squared would be opening from the top. So that's how those graphs would relate to the graph of y is equal to x squared. What we've seen in this video is a transformation that occurs when you put a negative in front of the a value. So if we just put a negative in front of the a value, that's a pure straight up reflection. But if we make the a value either larger than 1 in addition to adding a negative value, what you're doing is you're now stretching, making it more narrow, and reflecting. If you make the a value less than 1, so for example 0.3, you're now making the graph more compressed or wider, and you're reflecting. So it's kind of like two transformations happening at the same time with that. So in the next video, we're going to finish off with our conclusions and a few examples that we're working on together. You can take a look at the graphs that I did not graph here, the y is equal to negative 0.3 and y is equal to negative 0.6 in the solutions that are posted online. Try to graph them yourself first, then compare your work to see if you were able to graph them appropriately.